So we're going to be graphing quadratics using x-intercepts. So the very first thing I want you guys to know is what form is this equation in right now?
Standard.
Standard, good. I don't know the actual name, but you're right. We have standard form, okay? Now, the question says to graph using x-intercepts. Which of the forms helps us find x-intercepts? We have standard, vertex, and factored.
Factors.
That's right. Factored. Right. Factored helps us find x-intercepts, which means what process do we have to go through to get standard to factored? What's it called? Factoring, right? Makes sense? Factoring. Great. So, the first step to factoring is we always look for a common factor. Now, what we've historically done is always work with the first term being a positive. In other words, we want to factor out a common term of -1. Okay? We can't take 2 out because this is a 1, but we want to use a common factor of -1. We're going to take it to the outside of this equation. Yeah. So the -1 becomes the common factor, which you would do this way anyways. And we're left with 2x squared minus x plus 6. Once we've taken the common factor out, what we're going to want to do is we want to factor this trinomial here to go from standard to vertex form. So in this case, we find the factors of the first term. What are the factors of 2x squared?
1 and 2.
Yeah, 1x and 2x. And then we're going to find the factors of the last term, press C, 6 and 1 and 3 and 2. Excellent. Okay. We're going to put them into our columns. Now we know the red column is going to represent our first term. So our first term, one of them is going to be a 2x and one of them is going to be a 1x. There are no other columns. We just have to figure out which of the second column we're going to be using. Okay? Whether it's 6 and 1 or 3 and 2. We know we're going to multiply the columns together, and their product is going to add up to what? -1x, right? So let's trial and error this. 6 by 2 and 1 by 1 will give us 12 and 1. Any combination of that make -1? And let's go across. 2 times 1 and 1 times 6, that gives us 6 and 2. Any combination work there? No. So we know that the first column doesn't work. Which leaves us with the last one. We just got to figure out which numbers we multiply by which. 2 by 3 and 1 by 2 gives us 6 and 2. Is that going to work? No. So we go diagonally. 2 and 2 and 1 and 3, that will give us 3 and 4. Will that work?
Yes.
Okay, so I'm going to write these in permanent pen now. So we know if we multiply the 2 by the 2 and the 1 by the 3, we're going to get 3x and 4x. Now, in order to add to -1, which of those two terms needs to be a negative? 4. So now we have to work backwards. What did we multiply by to get -4? We did 2x times -2. Oh, is this question written backwards? Give me a second. Let me make sure this question. Now, I apologize. This question originally said +6. So let's work back. If this was +6 and we factor out -1, what does that become? That's right. Okay. Which will now allow this question to work, because the other way it was not going to work. So, -6. So we work back a little. I apologize. So now that we've created this -2 times 3, what is -2 times +3? Okay, so we know that these factors work. So what we're going to do now is we're going to write y is equal. We don't get rid of our common factor. It stays on the outside, and we have 2 brackets. The first terms are going to come from our red column. And it doesn't matter where I put what. In fact, I'll put the 1x in the first one and the 2x in the other, just to show you guys that. Okay? Now, our second terms will come from this green column. But the important part of it is, whatever I multiplied the 2x by has to go into the opposite column. So because we did 2x times -2, the -2 goes in the opposite column. Okay? So we have -2. And then, because we multiplied the 1x by +3, it goes in the opposite column. So +3 goes in the opposite column. Okay. So, y equals -1, x minus 2, 2x plus 3. We're now in factored form. To find x-intercepts, what do I have to do from here?
Basically, with the other one, so you have to divide. So it would be x equal 2 over 1.
Okay, I see we jumped a step.
X equal.
Let's talk about a graph. On a graph, in order to find an x-intercept, so when it crosses these points, what does our y value have to be?
0.
So what we need to do is set this y equal to 0. So then we have 0 is equal to negative 1, x minus 2, 2x plus 3. Remember, we're trying to solve for our x values, which means we're isolating x, which means we need to isolate this bracket and this bracket. So this negative 1, we need to move to the other side. To move it to the other side, what do I have to do? Because it's multiplied by?
Make it a positive. Move to the other side.
No. We need to divide by negative 1 because it's multiplication. So we divide 0 by negative 1. What is 0 divided by negative 1? 0 equals, these negative 1s create a 1 or cancel out, x minus 2, 2x plus 3. Okay. Now, again, the idea is that one of these brackets is going to be 0, because in order to multiply by something and get 0, 1 must be 0. So we're going to split the question and test for both. We get x minus 2 equals 0, and 2x plus 3 equals 0. Okay? To solve for x, we move 2 over, we get x is equal to positive 2. And here we move the 3 over, we get 2x is equal to negative 3. Are we done? I still have to isolate x. What do? Divide both sides by 2. What is x equal in this case? Negative 3 over 2. Also known as what? 1.5. Okay. So, negative. Good. Excellent eye. So, our answers. Our x-intercepts are positive 2 and negative 1.5. Now, we've done this yesterday, and this is all stuff we already know. So we have negative 1.5, and we have positive 2. These are our two x-intercepts. Now, we want to actually be able to graph the rest of this. So with this information, we're going to find the vertex. And what's going to happen is a vertex, because these things are symmetrical, are parabolas, the vertex is going to go right in between those two. It's also known as the axis of symmetry, the middle of this. So here is a formula for axis of symmetry. We call it the axis of symmetry. Okay? Also known as, I'll call it just AOS. Is equal to, they usually write it as R plus S divided by 2. The R and the S are x-intercepts. So you might want to think of it as AOS is equal to x1 and x2. And those x's are our intercepts. Okay? Divided by 2. However you remember this formula is fine. Just make sure you remember how to do it. So our 2 points were positive 2 and negative 1.5. So AOS is equal to 2 plus negative 1.5 divided by 2. What's 2 plus negative 1.5?
0.5.
0.5 divided by 2? 0.25. Good for you. So, positive 0.25 is almost like a quarter. You could say. What that means is the axis of symmetry of this is going to fall just beside the y-axis at positive 1.25. And we're going to put this on a real graph. This is just a rough sketch to start. Now, this information is also part of our vertex. Our x and y value of the vertex, well, our x value is 0.25. What we need to find now is the y value. This part's important. To find the y value, we need this x value. And what we do is we either plug it into the factored form or we plug it into the standard form. Both will work. We plug in our x value for it. So I'm going to plug it into the factored form. Actually, maybe I'll do it on both if I have a little bit of room. Yeah. What we'll do is we'll split this question right down the middle, showing that no matter which way you do it, standard or factored, you'll still get the same answer, as long as you use the right standard or factor form. Our standard form read y was equal to negative 2x squared plus x, and then technically it was plus 6. Our factored form was y was equal to negative 1, x minus 2, excuse me, 2x plus 3, is that right? Excellent. All right, so we're finding the y value of our vertex. We already have the x. We're looking for the y. That's what we're trying to find. The x is 0.25. So whether you want to use it as a fraction, 1/4, or 0.25, you'll get the same answer. We'll go 0.25 because I'm sure you guys are more used to decimals. Personally, fractions would be easiest. Y is equal to negative 2 times 0.25 squared plus 0.25 plus 6. We'll do the left side to start. This then equals, what's 0.25 squared? Help me out here, calculator.
0.0125.
Okay. And then 6 plus 0.25. Excellent.
Are you going to make this?
Yes. Negative 2 times this. It's going to be what? Good. Plus 6.25. 6. Excellent. Yeah. Are you sure? Did we make a mistake here? 0.25 squared is what? 625? Okay. So we got to correct some stuff. Yelled out some wrong information. What is 2 times that? And then what's negative 2 times this number? Do you guys know how to use calculators?
Is it 6.25 or?
All right, give me a calculator if you don't know how to use it.
Oh, it's 1.25.
It's what? Excellent. There you go. Negative 1.25? It's definitely negative. Negative 1.25 plus 6, 5 on the dot. Okay. Our other option, negative 1, 0.25 minus 2, 2 times 0.25. We plug 0.25 in for the two x values. We solve brackets first. Negative 2 minus 0.25 is 1.75. 2 times 0.25 is 0.5, plus 3 is 3.5. And we got to multiply those together. 1.75 times 3.5 times negative 1 will give us negative 6.125. These are different answers, so there has been a massive error here. I'm going to pause this and teach you how to use it. Okay, so in the end, our answer was 6.125. Okay? Should have been positive. Now, somehow the hardest part of doing this question was using the calculator. Should have been the easiest part. So our vertex is 0.25 and 6.125. So let's go back up to our rough sketch. That means the y value is at positive 6.125. So we have 3 points along our graph, which means we can now connect them, that being the vertex, and those being our x-intercepts. This would be our parabola. Okay? On a real graph, we'd have to be quite precise, and it would be a lot easier. But this should have been the easiest part, plugging the x in to find our y value. Oh.